Hi everyone, my name is Shada Munungfu. Today I would like to present my final project in the class Deep Learning with Big Data. Let's get started. Have you ever heard about CNN? According to the lecture in the class, Convolution Neural Network or CNN is one of the most popular algorithms for deep learning. CNNs are useful for finding patterns in images to recognize objects, faces, and scenes. By learning directly from the image data, using the pattern to classify image, and eliminating the need for manual feature extraction. Basically, CNN are a combination of two main subnetworks, such as the first one, the feature learning subnetwork, is learn or extract the features from input. Which comprise of the convolution layer, activation functions, and the pooling layer. It's over here. And the second is gonna be the fully connected subnetwork. It processes the output from the featured learning subnetwork and finish the job. Basically, the CNN applications are widely used for the object recognition and computer vision such as face recognition, self-driving vehicles, and image classification. In our project, we're gonna do the image classification. Okay, for the content that I would like to present it today, it's about the computer vision that classify the images that have total in 5 parts. And the first part, I will provide the computer vision example that the CNN can use to classify. The second part, I will show the step how to upload the CIFAR10 dataset to the virtual machine. In the third, fourth, and fifth parts, I will use CNN model to classify the image of the CIFAR10 datasets and tuning the CNN model to get the best accuracy. For the first part, I'm gonna show you the example of the computer vision that can use for classify the datasets. The name of the dataset is the fast food classification. It have 10,000 images. That is the color image have 256 times 256 pixels. They have 5 classes such as burger, donut, hot dog, pizza, and sandwich. Basically, they have 2 parts. So the first part is gonna be TensorFlow that divide to training 7500 and validation datasets have 2500 images. But in the TensorFlow, it have the data structure in TF record. That means it's already resized to 256 times 256 pixels. But in the second part, we have the raw image that divide into the training 7500 and validations 2500. In the raw image, the data structure of the raw image is JPEG. This is the example of the training datasets. This is the example of the image in validation datasets. Alright. In part 2, as I said at the beginning of the slide, for part 2, I will show you the step how to upload the CIFAR 10 dataset to the virtual machine. To download and upload the dataset to remote server, we have to upload the dataset in two parts. The first part, we have to upload the dataset to the virtual machine's instance in Google Cloud Console. And then we're gonna upload the dataset to the deep learning virtual machine. So for the first part, uploading the dataset to Google Cloud. So at first, you have to download our files, which have 7 files over here from the canvas, and then save it into your computer or local machine. After that, you have to open the Google Cloud Console and then run the instance and open the shell terminal by click over here and then open the browser windows. It's gonna pop up your new window. So because we have to put our file under the CIFAR 10 data subdirectory, so at first we have to create the CIFAR underscore 10 underscore data by using this command. By using this command, mkdir CIFAR underscore 10 underscore data, and then you just upload all the file by clicking the right hand side on the top over here, upload file and open, and then you click upload file. So after you upload file to the main directory, so you have to either copy or move to the specific subdirectory over here. I used move and then following with the name of the file and the subdirectory over here, as you can see over here. So I put in there and move the file to this subdirectory. After you download every file and you transfer to the subdirectory over here, so as you can see, I already moved the file to my specific subdirectory. Okay, after that we have to upload the file that our professor gave us. So I just download into the instance under the subdirectory jp underscore ntbk by using this command. You can see it's already in there. Okay, from the part 2, we have to upload the dataset to the virtual machine. So our virtual machine, as you can see over here, we have to create the subdirectory CIFAR 10 data and then just upload all the file into that by clicking open. Here it's already there. The third part, we're going to build, train, and test the CNN model on CIFAR 10 datasets. We're going to classify the all images, and about the dataset, it's 32 times 32 pixels with 60,000 color images with the training 50,000 and the testing 10,000, and it divided into 10 classes. That is the plane, car, bird, cat, deer, dog, frog, horse, sheep, truck. To train the dataset, we're gonna set the filter 32 times 32 pixels image should be fit well with 3 times 3 size of the filter, and then we're gonna set the step of the training 5,000 steps, and then we're gonna test after every 100 steps of the training. This is what we have from the file that we uploaded. It has set path for data folder and load data. And it has a display several example. I believe this is the frog. And it have the part for encoding part and setting of the image data. Okay, the thing that we have to add more code is define the support function to build, train, and test the CNN model. And then we have to build the first convolution neural network and the second one, and the rest of it. So let's view the first part that we have to add is define the support functions. We define the weight in filter. We define the bias. We set up the convolutional layers. We set up the layer layers. We set up the pooling layer. We set up the fully connected layer. Here the first. And then we're gonna create the real convolution layer. Okay, by create the first convolution layer and perform the computation. So we used the filter 3 times 3 and put the input channel in 3 because it's the color red, green, and blue. And the output channels is 32. Same as the layer over here. And then we're gonna create the second convolution layer and perform the computation by using also the filter 3 times 3. Input channel is gonna be 3 and the output is gonna be 64. It's because it's gonna be double from the actual image. So it's gonna be like this, and also the layer is gonna be like this: 3, 3, 32, 64. And after we create the first and the second convolution layer, we have to flatten the data. We flatten into -1 is mean like we're gonna remain the size of the image data 8 times X and 64. And then we clear the final fully connected layer. Output is size 10 because we have 10 classes. And define the loss function, we use the softmax. This is the important step that we have to set the learning rate. So I set the learning rate into .001. Okay, and we have to set the step. So each time of the training, we used 5,000 steps. And in each step, 5,000 steps. So we're gonna batch, and here we set the batch into 100. To summary, so to train and test the CNN model on the CIFAR dataset, this is the result. Okay, as the result of it, because it's RGB color and the accuracy is quite low, which the accuracy is like about 69-70%. Even though the size of the filter is 3 times this, it's make the model more complex, but it's still like very low, 69-70. In part 4, in this part, we will compare the performance in different data such as the MNIST datasets and the CIFAR datasets. The MNIST dataset is the binary images that compose of the white and black, or we can call grayscale, with 28 times 28 pixels. It's come up with 70,000 images. They said the training dataset is into 60,000, and for the testing dataset into 10,000. It's divided into 10 classes of the handwriting digit from 0 to 1. Also, the different dataset that we do is the CIFAR 10 datasets. It have 32 times 32 pixels in RGB color of total 60,000 image. They divide into the training for 50,000 and for the testing 10,000. When we train the model, the settings are similar, such as the learning rate of 0.001 and the filter is 5 times 5, and we train the model with 5,000 steps and set the test batch into 100. The left hand side is gonna be the setting of the filter and the first convolution layer of the MNIST. The right hand side, we set the same thing to CIFAR 10 dataset. And also we set the second convolution the same. Okay, we have to reshape the dataset into the before we fit it into the fully connected convolution layer. We set into -1, 77, 64, but for the CIFAR 10 we set into -8 times 8 times 64. Okay, and we set the step like the same and also the batch the same. Okay, after we run on 2 datasets, this is the MNIST dataset and the CIFAR 10 dataset, we set the step into 5,000 steps of training, and every 100 step we gonna take a test on the model. So as we can see at the very first step, so the accuracy just only 14%, and after that 100 step, so the accuracy is very high. It just like jump into 95%, and after we run it at the end at the 5,000 step, so we got very high accuracy, that is 99.01%. And when we after we run the model and we do the setting on the step 5,000, similar to the MNIST dataset. So the very first step, it is only 10%, and after 10 step we do the test, it jumped a little bit, just only 38%, and after that we do the test every 100 step, you see, and it's increased just a little by a little at the end. So it's just only 67-90%. That means MNIST model is have very high accuracy, more than the CIFAR-10 models. And the result, as we can see, the accuracy of those datasets are much different. With accuracy of MNIST datasets is 99.01%. The accuracy of CIFAR-10 is just only 67.90. The reason of the gap is not about the number of the image, but is associated to the image site. To be clear, the MNIST dataset is a binary image. We can say it's the grayscale, which is easier for the CNN model to classify the class image than the higher pixels image, like CIFAR-10 datasets. In part 5, in this part, we will improve the performance of CNN models on the CIFAR-10 datasets. I try to improve the CNN model on CIFAR-10 datasets by increasing the filter from 5x5 to 4x4. Because the smaller filter, the more complexity of the model it gets. So it will increase the accuracies by theory. And I also decreased the learning rate from 0.001 to 0.0001, because the less the learning rate, the more accuracy it gets by theory. So as you can see, I already decrease from 5x5 filter over here, but the other is still the same. Other parts. Also, I adjust the filter from 5x5 to 4x4 over here. But for the reshape part, I still remain the same number. Okay, and we already also set the same step and also the same batch. The result of the last part, when we try to improve the model, so I decide to like do the filter just only 4x4 from 5x5. Let's see the accuracies. I guess it's like at the first step is less than the 5x5, because 5x5 on CIFAR-10 is 10. Wow, 10%. And for the accuracy of 4 times 4, but be setting at the three zeros 1 on the learning rate is kind of learning like little by little. That's why like for the first step it's just only a little bit, and on the 100 step it's just only 31%, which is also less than the 5 times 5 filter at the end. So the result of the accuracy still less than the 5 times 5 filter on the part 4. After we try to improve the accuracy of CNN model for CIFAR 10 datasets, we decrease the learning rate from 20 to 30 and reduce the filter from 5 times 5 to 4 times 4 to get the better accuracy. However, the accuracy after try to improve is not better than the model from part 4. To summarize this result, the size of the filter is smaller and the learning rate is not smaller, do not ensure that the CNN model will be improved. As you can see the accuracy after we decrease from 5 times 5 to 4 times 4 and decrease the learning rate to 20 to 30, it's supposed to be like the accuracy supposed to be higher, but it's not. But definitely for the part 3 it's the best one, because the filter more smaller, more accuracy. We get 69-76% of that. Okay, for the conclusions, the binary image, which black and white, is easy for CNN model to classify the image than the color image, because the model process the image from MNIST data faster than processing the CIFAR 10 datasets. And part 4, the CNN algorithm learn and classify the small image like from MNIST dataset, which are only 28 times 28 pixels, better than the larger image from CIFAR 10 datasets, which is 32 times 32 pixels. For the large part, the filter 3 times 3 is fit to the CNN model that processing 32 times 32 pixels, then the 4 times 4 and 5 times 5 filters. Let's say like the smaller filter, the more complexity of the model and the higher accuracy. For the theory, the learning rate is smaller, the more accuracy is get. However, adjusting the learning rate and filter size to smaller does not ensure that the CNN model accuracy will increase. Thank you.